So in Galactic Battleship, you would place your ships on the map, and then somebody else would try to hit them by saying coordinates of the ship. Now, I found that this game was kind of cool, but took a long time to like teach everybody and practice and all that stuff. So I'm just going to ask you to analyze, like, what was that spot called? Please label it. Zoom in on it and label that spot. It was something, comma, something. Hint, R, comma, theta. Graham, what say you? What was the R?
I'm not sure. I was gone yesterday.
Haven't had a chance to watch the video yet, apparently. All right, John Rafferty.
3, 2 pi over 3.
Yep. See how this right here is at 2 pi over 3? That's the angle we're going out. And how far do we go out? 3. So it's called 3, 2 pi over 3. All right, so that is a spot. Let's go find a more completely distinct, different spot. How about that one? What's the name for that spot? It's R, comma, theta. So the radius first is 1, 2, 3. So 3, comma, 5 pi over 4. But wait, wouldn't there be another way you could have said that? Yes, and that's the first type of question, which is if you're given a point like this, give it a name with a negative angle. Well, that implies that the R is still 3. 3, comma. And it's still going to be in pi over 4s, isn't it? But it's going to be a negative, how many pi over 4s? 3 pi over 4. 1 pi over 4 would be way over here. And this would be 2 pi over 4. So this one was negative 3 pi over 4. Okay. Now, we're skipping to slide 6. I told you to memorize a few things. I gave you this list because I wanted you to have a chance to start memorizing it starting on Friday, and maybe by this day you'd still remember a few. One of the answers is r sine theta. Try to put it in the right spot. Y equals r sine theta. Do you remember that sine goes with y? So then this shouldn't be too much of a stretch. And then the other one's r cosine theta. Let me explain why. You should memorize these because that is a way to translate an equation that's just in polar, like r equals 7. That's in polar. There's no r's in rectangular. There's just x's and y's. So if I want to translate this into polar, then having something like this helps. But actually, there's a different one that would be better for this. Does anybody remember what we did with the x and the y related to the r? It was 3 days ago. Oh, say it.
R equals square root of x squared plus y squared.
Square root of x squared plus y squared. He's right with one little thing in the front of it. Do you remember what was in front of it? Because of the whole, when you do the square root of a variable, you need something. Plus and minus. That is a correct answer. So that plus and minus, the square root of x squared plus y squared. Now you might be like, I don't remember ever seeing that before, but do you remember seeing this? X squared plus y squared equals r squared. Wouldn't that just be the Pythagorean theorem applied to this? Right? X squared plus y squared equals r squared. That's not like a big stretch. And that just means that they square rooted both sides, see? And because there was an absolute value here, you have to put a plus and minus there. So r equaled all that. Okay, so the last one, you see sine and cosine represented here, so what's the one that's missing?
Tangent.
So everybody just write tangent theta, and then look at the picture and try to figure out what it is. Allison, what is tangent of theta? Yeah, y over x. This side, rectangular. Because it's got x's and y's. This side, that's the polar side. Because it's got r's or thetas, or both. When would you ever use it? Well, what if you had y equals x? Would you agree y equals x is an equation? Is it in rectangular? Yes. We want to change it to polar because that's the typical question because we're in the unit called polar. So how do I change that to polar? Well, Woody just figured out what x was a second ago. R cosine theta. So I put that here. Is it changed now? No, now it's half polar and half rectangular. It's a little bit like a chimera. Do you guys know what that is? Half human and half something else. There's rumors that there are that they are trying to grow half pig and half humans in a lab so that they can harvest their organs for the humans. And I know, he's like, no, it's impossible. But anytime you find yourself saying that, ask yourself, maybe it is possible.
No, not like it's
Okay,
not
go ahead.
possible, but like that's super like ethically really weird.
Yeah, it is definitely a problem ethically. Now, so, because I hear you, if there is, like, if they look like humans, but should that even be the definition of, like, why we should care about their lives? If it looks like a human, then we should be like, oh dear, we're doing something terrible. Like, because aren't there other things that would be terrible to do even though they don't look like humans?
It's okay to kill all of them.
So is it okay to kill everything that's not a human? Is it okay to kill an AI? What if you make an AI? What if you make an artificial intelligence that's smarter than a human? Is it okay to kill it?
Yeah.
It's a robot. It's technology.
Okay.
They're a living
Anything that
human
lives.
being.
All right. So anyway, we can probably get off this crazy ethical train that I started talking about. But this is a half polar and half rectangular. Don't ever leave your answers like that. Okay? We always have to either get them to be all the way polar or all the way rectangular. What started rectangular, let's just finish it. How do I get this to be completely polar?
R sine theta.
Yeah, the y here is r what?
Sine theta.
R sine theta equals r cosine theta. Now, usually people are like, so what do you solve for? Well, it depends. Most times they don't ask you to solve, and then you're done. If it's got only r's and thetas in it, you're done. But could we solve it for something? Yes, we could. Now, before we do that, though, I want to look back to my original problem and say there was another way to do it. What do you think?
Just divide y by x.
Ooh, yes, divide both sides by x, and then we'd have this. And what is x over x? 1. So then what's y over x? Ooh, I've got it right there. Tangent. So I can replace this with tangent theta. And again, one of the most important questions is, am I done? Is this in polar? Yes, it is. It's got only r's and thetas. It doesn't have any x's and it doesn't have any y's. So this is only in polar. What if I wanted to solve it for theta? You could. How do you get theta alone? Inverse tan. Don't have to do this. I'm just saying, what if they wanted it solved for theta? Inverse tangent of 1. That almost looks like a math problem. Like you should know how to do inverse trig. Quick reminder, inverse tan is only allowed from here to here. So then I cross this out. And it really started out as tangent of some angle equaling 1. And then I would say, oh, that's positive. So then it must be up here. So it can't be there. Otherwise it'd be negative. TOA is opposite over adjacent. 1 over 1 equals 1. Ooh, 1 square root of 2. I know that one. So then what's the angle? Theta must be 45. Pi over 4. Good. So is it okay to say your answer's with an inverse tan? Yeah. Is it okay to simplify them further and say what they actually are then? Yeah. What's the inverse tangent of 1? Well, I just drew it for you. It's right there. So what's the angle? These are always asking for an angle, and it's pi over 4. That's the best answer. So that's, wait a minute. Mr. Server, you started with y equals x, and you ended with that. I know, that's weird, but it's true. This is a line. You guys know what it looks like, don't you? Y equals x, that's this line that goes like that. Guess what happens if you graph theta equals pi over 4? It's that angle with any radius. With a radius of 0, puts you there. Radius of 1, puts you there. Radius of 2, 3, 4. Any restrictions on decimal angles? No. So then you can have things in between them too. And look at that. It's making that line, isn't it? All right. So, moral of the story. Well, that's a rectangular line. That's a polar line. So just saying an angle gives you a line? Yes, it does. So does just saying an r. R equals 3 gives me a curvy line. Looks like that, doesn't it? Okay, so what's the rectangular equation for that? Take a second. Think about it. This isn't rectangular because it's got an r in it. Could you replace r with something? Oh, yes, you could. Try it. Try writing me the rectangular equation for that circle with a radius of 3. Pausing while you do that. Okay, so here's a trick that I think you're going to like. Would you agree that I can square both sides of an equation? Cool. Now, r squared is 9. And do you agree there's a nice clean thing we can replace r squared with? What's r squared equal to? No. R squared. X squared plus y squared. And 3 squared is 9. Isn't that a nice clean equation? Your other one has a big square root in it and a plus and a minus and all that stuff. So is the other one better in any way? Well, I guess if I had asked you to solve it for x, you'd have to be able to do that. Or if I had said solve for y, you'd have to be able to do that. But I think squaring both sides is a genius move. All right. I do want you to understand another alternative. If r equals 4 cosine of theta, would you agree that that is in polar right now, right? Can I get it to turn into rectangular somehow? Yes, I can. And I'm going to give you this hint. I just told you to square both sides, and I could. But I could also do one other thing. I could just replace this r with that thing we told you it was, square root of x squared plus y squared. A plus and a minus in the front. If you're good enough at memorizing and you memorize that, cool. And then r cosine theta is kind of like this, isn't it? Except we know r is 4. Do I have to replace that to get, yeah, I can't leave a theta in my answer. So then, isn't this kind of like y?
No, it's X.
Okay, isn't it kind of like x? Can I just slap an x here? Is that the same as 4 cosine theta? No. Could I put a 4x? Okay. So I have one last, and I have some, I'm questioning if I just did that right, but that's all right. We're going to move on and look at some other problems that are like it. But you can't argue with 4 is equal to 4. The parts that bothering me is cosine theta is equal to, wait a minute. I'm just going to write it out. I'm going to draw my little picture. This is something you should go back to, too, when you're stuck. X, Y, and R. So cosine of the angle is X over R. That's a fact. So couldn't I replace this with R cosine theta? But I had a cosine theta, not an R cosine theta. Oh, it's making my head hurt. So times by r on both sides, see? X is r cosine theta. So what if I just have a cosine theta? I think this is right. There's something bothering me about it. So maybe I'll figure it out later. We'll see.
Wait, can it be the, because isn't that technically r cosine theta on the top, 4 is the r? Couldn't it just be x over 4 instead of 4x?
Maybe it is.
I don't think
It's an interesting question.
you have r equaling two different values
All right.
in the same equation.
Let's go to some more normal problems. So
If 4 is
This one's-
technically r,
this one's bothering me, and you know, I hope you get. This is complicated enough stuff that every now and then the teacher's going to hit a problem that they're like, no, I'm not sure I'm doing it right. That's okay. That happens. All right. So as long as eventually we figure it out, we'll be good. All right. I'd like you to start with this green page. Draw that. That's a point. Pause for a second while you work on that. Okay, so let's first do this. 2 comma negative pi over 6. Did you know that negative pi over 6 is that away? And then 2 means that this radius was 2. Raise your hand if you graphed it in the right spot. Cool. Now, let's just take a second and say that's not all they would ask. They don't want you to just graph that. That's too easy. That's like regular pre-calc. What if we had to say, give me 3 names for this point, one of them where it uses a positive angle. So instead of 2 comma negative pi over 6, give me the same point except with a positive angle. And give me one where the r is negative. And then we'll have 3 different ways you could do it. You could leave it the way it was fine. But these are other ways to write it in polar. So if it's going to stay positive, well, then it has to be a 2 here. But then what is negative pi over 6 the other way? Well, if you go all the way around this way, it'd be a whole bunch of positive pi over 6s. Who's got it? Say it if you know it. 11 pi over 6s. Correct. But what if you wanted to be r to be negative? Do you remember that deal where you go over here and use the shadow point? That point right there is 2 comma what? That's more than pi over 6. 5 pi over 6, yes. Now I use that shadow point and I say, well, what if I put it over here then? It would become negative 2 comma 5 pi over 6. Notice the angle doesn't change. So you copy this point over here, except you make the r negative, and there you go. There's one with a negative and a positive. How about a negative and a negative?
-2 comma -7 pi over 6.
This spot here would be negative 7 pi over 6. 2 comma negative 7 pi over 6. And that could go down here and be negative 2 comma negative. Nope. Yes, negative 7 pi over 6. You can only change one of the 2 things. By bopping over here, you don't change the angle, you just change the r to be negative. So there are 4 different names for that point, with negative r's, negative thetas, positive thetas, all these different options. Okay, then there's only one other thing. If this is 30 degrees, would you agree that just looking at the triangle, that it's a 30, 60, 90 triangle, would you agree with that? Then would you agree this is a 1 and a square root of 3 there and there? Okay. So then, would you agree that I just found the rectangular coordinates for this point? And it's the square root of 3 comma negative 1. Got changed up. We were doing polar, and then all of a sudden, we changed to rectangular, and that's kind of the theme for today. It's going back and forth between rectangular and polar. This is rectangular, how you'd get there. You'd go over and then up, down. You go over square root of 3 and you go up or down negative 1. See, that's the rectangular coordinates for this same exact point right here, which was in polar. Somebody's getting a call. You may want to turn your phone off or something. Okay, if it's mom or dad and it's a crisis, you can go in the hall and take it. All right, so would this right here, the 0.11, would that be, if I said 1, 1, would that be in rectangular or would that be in polar? If I said 1, 1, and I'm saying that this dot right there is in rectangular. Tell me what it is in polar. It's always r comma theta, so what's the r? What's this side here? Square root of 2. 1, 1 root 2. You ever heard of it? Square root of 2, comma. And then what's the angle? It's that angle, which is 45 degrees, aka pi over 4. Root 2, comma, pi over 4. Are you good with that? All right. So then tell me, if I told you -1, comma, square root of 2, would you tell me what that is in polar? Because it's rectangular right now. Do you know the way I can tell? Because there's not an angle. So it must not be in polar. Polar would have an angle in it, right? So what would it be if it had an angle in it? R comma theta. What is the R comma theta for that? I would always draw a picture. So much easier. Draw a picture of it. Once you look at the picture, you can go, I need an R, I need a theta. Eleanor, which quadrant are we in?
The second.
Yep. And that's -1, and that's the square root of 2, and then this last side right here, this red side is how long? Don't know that one, do you?
No.
Yeah. So, and I'd go, okay, then this is not, I think some of you probably thought it was a 30, 60, 90 because it's got a 1 and a square root of 2, or maybe the 45, 45, 90, but it's not either one of those. Then how do you say the angle? Hint, use tangent somehow. Well, this isn't going to be that hard. You figure out how long the radius is so that you can say the radius. But what's the angle going to be? One thing at a time. That is square root of 1 squared plus square root of 2 squared. Would you guys agree that's the square root of 3? Okay. Do you agree that is not one of the triangles we memorized? Okay. So then, we now know the length is the square root of 3, though. And then what's the angle? Tangent of the angle is root 2 over -1. So I ask you again, what's the theta? Inverse tan, there it is. Inverse tan on both sides. Inverse tan of root 2 over -1. That's it. That got weird. Only because we didn't know the angle. Whenever you don't know the angle, like it's either 30, 60, 45, one of the ones you know, or it's not one of the ones you know. If it's not one of the ones you know, you just use inverse tan. Let's do one more like that. This time I'm going to draw the picture for you. That's 2, that's 5. What is its name in rectangular? That's too easy. -2, -5. But what is its name in polar? I'll pause while you try that one. Okay, I'm going to do square root of 25 plus 4. Would you get square root of 29? You guys add that too? Okay, good. So then my first part of my point is always the r, and that is square root of 29. And then there's my theta. Have you anybody memorized the -2, -5 square root of 29 triangle? Probably not. So then you use inverse tan, and you can just go straight there. If you can't go straight there, then you just write tangent and try to figure it out. Tangent of the angle. Pausing for a second. Okay, so tangent of theta is tau. Opposite over adjacent. Opposite's -5. Adjacent is 2. Oh, -2, thank you. And then the negatives will cancel. So there we go. And then, is that an angle? No, but I can solve it for inverse, with inverse tan. So I go inverse tan here on this side and inverse tan on that side. So, this is inverse tan. Make myself a little more room. Inverse tan, 5 over 2. That's how you do it when you don't know the angle. Yes?
We always use tangent.
Yep. It's just, I know, we could have used sine, cosine, or tangent, but these are usually nicer sides. That's one of the reasons that we do it that way, because square root of 29 isn't a very nice number. And it's just a convention that's one of these, like, we always use tangent for this kind, even though you could use other numbers. A lot of times you have the two legs and you don't have the hypotenuse, so, okay. Here's another reason, too, that I'm not thinking of, but inverse tan is the way to go. So there you go. All right. I figured out that other one that we talked about, and I kind of got stuck. I'm not even sure exactly where I got stuck, but here's the original problem. R equals 4 cosine theta. Everybody write that out again. And I just screwed up something simple. First off, is this in rectangular or polar? This is polar. You know how it's in polar? It's got r's and thetas. There's no x's, there's no y's. So then the challenge would be change this into rectangular. So if you try to do it right off the bat, that's going to be the part that really messes you up. I told you could square both sides, but that isn't the best way to go. You should times both sides by r. And then for some reason, I just could not process this. R squared is x squared plus y squared. That part I had right. And then for over here, it's super simple. R cosine theta is something. What's r cosine theta? It's x. So this is 4x. And that's it. That's the end. I was making it more complicated than it was. That's it.
So you multiply, when you multiply r, you don't multiply it both. You don't make it 4r, you make it, you put
I could have put the r in front or at the end, but do you agree that the r could have been in front or at the end or where I put it? The r could be in any of those spots. So you might as well put it right by the cosine, because r cosine theta is something we know. That's right off of our new memorized sheet. R cosine theta, that's x. So then I can replace that with x, and there you go. There's your answer. Now, could we make it more complicated by saying solve for y? Yes, we could. And since we have something like that, I want you to try it. Solve for y. Take a minute. Because see, a lot of times we say you don't have to solve for anything, but sometimes you do have to solve for something. I hope you're all starting by subtracting x squared from both sides. And then I have y squared is equal to 4x minus x squared. You with me so far? Is the y alone yet? No, so you got to do another step. Square root, square root. Is the y alone yet? Kind of. I just did it wrong on purpose. When you square root a variable, there's an absolute value, which then means to get that off of there, this y could either be positive or it could be negative, right?
So you put plus or minus.
Plus and minus right there. I'd really prefer to leave them in there and then just say the next step is that the final answer is plus and minus 4x minus x squared. There you go. Solve for y. It's just algebra. If that kicked your butt, you got to work on the top 20. It's algebra. Got to have your top 20 completely down. Sure, there's more than the top 20, but boy, you got to have those. Okay. So let's actually go through a few more of these slides and see if you're ready. I think pretty soon I'm going to tell you what the homework is and give you time to work. I'd like you to go here. And actually, yeah, that's where I want to. We are ready to start the homework. So let's start the homework together. The first one is this one. So everybody graph where you think that is. Just put a dot there. And then they just want you to give one where r is negative. The shadow point comes in. And one where the r is positive, but the angle's negative. And then one where r is positive, that's the easy kind, and, well, not that easy, I guess, considering you're starting with a negative r. And this one says they want the angle to be bigger than 2 pi. So whatever it was, just add 2 pi to it. All right, so one thing at a time. Where the heck is this point? If I was going to graph this point, pro tip, scribble off the negative. And just graph where is that. That isn't that bad. Negative pi over 4 is like that. And 2.5 is like this. And it's right so far. But wait, the actual point is negative. Do you get that means we have just sent it through to the shadow point? It's over here. That's where it actually is. This is where regular 2.5 comma negative pi over 4 would be. So this is where our actual point is. Now, they want us to give a few more names for it. One where r is less than 0, which we already have. And the angle's between 0 and 2 pi. That means positive. See, that's above 0, right? So, is there a way to change this angle right there, negative pi over 4, into a different angle that would have been positive? Yeah. You just got to go this way. And that would be a whole bunch of pi over 4s. Could you believe 7 pi over 4? All I'm doing is replacing the... Oh, wait, but this has got a negative 2.5. Sorry. I just replaced this angle with this angle. Now I've got my negative angle, but my negative r, but my positive theta. All right. Now what if I needed positive r? Well, then I just look at this point, which is over here, and say, what is its radius? Oh, it's 2.5. It's 2.5. And what angle would I need to get there? That angle right there. 3 pi over 4 is correct. And I get the interplay between the positive and the negative r, it gets confusing. And last but not least, they wanted one with a positive r, so that's basically this one. But now they want us to change this angle so that it's bigger than 2 pi. Just add 2 pi to it. Yes?
Why can't you just do negative 2.5 and then 3 pi over 4 instead of 7?
The reason I'm using a positive r is because in part B and C, they're forcing me to use a positive r. Do you get that the problem is forcing me to give my answer with positive r's? So that's why I have to use positive 2.5. Martin.
Isn't 3 pi over 4 bigger than 0? Not less than 0.
This is positive. You are correct. Did they want it to be negative?
They want it to be less than or equal to 0 for B.
Okay, so then don't overthink this. You know where 3 pi over 4 is, right? What would the negative angle be for that? So we can leave this the same. Say 2.5 comma, and then we can replace this. 3 pi over 4 is the same as negative a whole bunch of pi over 4s, negative 5 pi over 4. Now, if you wanted it to be negative r, then that'd be a whole different thing. So, yes.
So basically, when they give you a negative on the question,
Yep.
you're not actually going to graph it where the theta from the question is. You're gonna graph it based on like the shadow angle. Like that's the actual answer.
That's where you get the angle from. Yes.
Okay,
So let's just do one more. That's exactly like you just said. I just want to make sure that you get this. Negative 5 comma 2 pi over 3. This is a place. It's only one place. But the only reason I use the shadow point is because it's really hard to do this right off the bat without like changing this to a positive. So I recommend that to find this place, there's only one place that this is, but I would go to the shadow point first, which is always start by figuring out where is positive 5 comma whatever. Just find that and then realize that's not where we want to be because it's actually negative, but start with the positive one because otherwise it just kind of hurts your head. So where is positive 5 comma 2 pi over 3? Well, then I go to normal 2 pi over 3. Where is that? That's like here. I made that look too much like it was a 45-degree angle. I think it's more like that. Okay, so that's about where 2 pi over 3 is. Can you believe that? And then this is 5. But that's not where our point is because, remember, this was actually negative. So now I'm in a good enough spot, like I'm comfortable enough that I can go, okay, so that's where the shadow point would be. So my actual point would be like there. That is that spot. But it's helpful to have both because this spot is negative 5 comma 2 pi over 3. But to get some of the other names for this spot, if I know this spot, which is 5 comma 2 pi over 3.
I just don't understand how that's 2 pi over 3. Because that's not
This
where
is
it would be.
stop. I think this is 2 pi over 3. Would you agree with that?
Yeah.
Okay. Now, if all I do is slap a negative on it, do you know what that does to the point? If I put a negative on the r, if I change this from 5 to negative 5, do you know where you go?
Like reflection.
Yep, you reflect over there. Yep. But the angle has to stay the same. You'll never change the r and the theta at the same time. I get it. You're thinking, but this isn't 2 pi over 3 anymore. I know, it's not.
It is go the other way.
But if you wanted to give it a name that uses that angle, which would be negative pi over 3, then you'd have to use a positive 5. First, what you got to get through your head is that this spot right here, this 5 comma pi over negative pi over 3, would you agree, just make sure you get this, that spot right there, this spot here, would you agree that it is 5 comma negative pi over 3? Okay, so then when you want to do one with a negative, you have to go to the other side, go over here and say that's where the negative would come from is over there. And that is a different angle completely, right? So do you get that this point right here, 5 comma 2 pi over 3 is there? Does that make sense to you? That spot, this spot right here, would you agree that that's 5 comma 2 pi over 3? Good. And then this spot over here, would you agree that it is not, don't worry about the negative yet, focus on this one. Would you agree that this spot right here is 5 comma negative pi over 3?
Yeah.
Okay, good. Then do you get, I can't take and just change this to be negative. You don't also change the angle. You just change one of the two things. If I changed it to negative 5 and negative 2 pi over 3, that would not be here. All right, I get it. It's confusing. If you can just keep straight in your head that the positive of this point and the positive of that point, then just know if you ever move it to the other side, like if you want to take this one and you want to move it over, all it changes is the r.
So the angle's the same.
Yep. Yes,
So where is it when it's -5 and -2π/3?
good question. So let's say we wanted to graph -5, comma, -2π/3. So remember my advice, don't start with this. It's kind of like secant. Nobody graphs secant. They always start by graphing the sister function for it, right? So don't start with this. Act like there's no negative and graph that. Try to figure out what that is first. Everybody, please graph that. Where is 5, comma, -2π/3? And then we'll move it. Would you agree -2π/3 was there-ish? Yeah? Okay. So then, I'm going to call that spot, I christen thee 5, comma, -2π/3. But is that the spot I really wanted to find? No, because the original problem was -5. So I'm going to go erase this now and say, I really want -5. So then, you go through here, bloop, to the other side. That's where this point actually is. So now, you can't look at its angle and say, but wait, Mr. Server, this angle right here, that angle right there is 1π/3. I know, it is. So if you wanted to name this spot with a positive, sorry, I forgot to unmute my phone. If you wanted to name that with a positive, it would have been positive 1π/3. But the R, if I was going to name this spot the normal way, the R would be 5. So that's the spot, 5, comma, π/3. And this is here over on this side is 5, comma, -2π/3. As long as these two make sense to you, I'm going to highlight them. This one, does that one make sense to you? You guys get why that one is 5, comma, π/3? And this one is 5, comma, -2π/3? Okay. Then, if you want to bring this one over here, you'd change it to -5. So it would become -5, comma, π/3. And if I wanted to bring this one over here, it would actually become that. Yes?
When you go from -5, -2π/3 to 5π/3 was 5 change. And you said you can only change 1.
You're only changing one thing. You are correct.
So then why was the 5 turning to a positive?
This, if I wanted to bring it to the other side and make it positive, the positive of the shadow point to this would become 5, comma, -2π/3. When I'm saying when you change it, it's if you change it to the other side, if you actually move this point, if you move this point to the other side, all that changes is the number goes from positive to negative, the R. If you thought I meant when I take this point and I rewrite it, you have to rewrite both that and that. Both have to change. It's whether if it's about moving it. If I want to move the point to the other side to this shadow point, that's when only the R would change.
But if you're like renaming it, both of them can change.
If you're renaming this point, and yeah, if you're not moving this point, if you're just saying I want another name for it, then yes, both of them have to change. Yes. Because I can't just say, I'm going to call this point that was -2, I'm going to call it +2. You can't do that without also changing the angle. All right. So let's move on. And here is another type of question. I think you should cross these off, and you should do one that has an arctan in it. So we're gonna skip that one, but we'll do this one. So do those three, 17, 18, and 36. Then go over onto this page. I recommend you skip that one and skip that one. I don't think you need to do that one either. We'll just do the circled ones. And then on this page, I'm going to help you with with these two, and then you'll do the circled one. So this one, remember me saying, listen, that you square both sides? So then x squared plus y squared equals 9. Boom. That's all you have to do. Remember me saying you could times both sides by r? That's what I do on that kind. So you guys should do these two. You can hand me those yellow cards as you head out the door. That's all I got for you for the video for today.